Yeah, this problem we can do the different ways. Earlier, the same problem we did by using the friction analysis. Now we'll do the other method now, work energy theorem. So here the two methods will solve this problem. Yeah, first method you see. Yeah. So this is a work energy theorem. What is the work energy theorem? By using work energy theorem, we say work done by all forces equal to change in kinetic energy. Work done. So here, what are the work done? You tell me now here. What are the work done by all forces here? Which will do the work? You tell me now here. And so external, there is no external force now. Velocity, the body moving. And so here we have a frictional force is there. Yes. Now here, which is the what is the work done now? Work done by the frictional force equal to change in kinetic energy na of m v square minus of m u square. So work done by the frictional force and frictional force. What is the frictional force? You tell me now. First of all, that is mu into n, and that is equal to mu mg. So that means how much the frictional force? You tell me now. Mu value 0.2 into 100. So this value how much now? So this value 20. Right. And how much the displacement now? Here displacement not given. X value we have to find. So this is what we can say now. These two opposite direction now. So minus 20 into x, which is equal to final velocity 0 now. So kinetic energy 0 and minus what I can say now of m. Mass is how much? 10 and initial velocity given now how much? 10. So that is 100. So it will come to be a 20x equal to what? Tell me now here. Yes. So 5 into 100 now. So that is how much this x value. So this value 0 will get cancelled. 5. 25 now. So 25 meters. This is the displacement. Yeah. This is the thing. Okay. Now the other method also we do this thing, same thing. Other method earlier we did recollect it once. And what is the other method we did in friction? We did this type of problem. If any body moving in the horizontal surface, what is the frictional, what is the acceleration is a minus mu g, acceleration, horizontal surface. So initial velocity of a body, how much now? 10. And the acceleration is how much now? That is minus mu g. That is minus mu value 0.2, g value 10. So this value will come to be a 2 now, minus 2. And then final velocity how much? 0. And we need to get the displacement now. We can use v square minus u square equal to 2as. Final velocity 0. This is 100, which is equal to 2 into minus 2 into s na. So how much this s value will come? This is 100 by 4 only na. How much this value? 25. Exactly we got the same thing.